is Sridhar B, Associate Professor in Mathematics, Freshman Engineering, Marri Reddy Engineering College. Okay, today's our topic will be probability and statistics. Under the probability and statistics, the topic will be random variables. So, we are going to discuss what is the meaning of random variable. So, simply as a definition, a random variable is a mathematical function. Random variable is a mathematical function that assigns a numerical value to each outcome of a random experiment. Whatever experiment you can do, you will get some outcome. For that outcome, we are going to assign a numerical value. So that's why we are assigning the outcome value to some other numerical value. That type of mapping is a mathematical function. Such type of mathematical function is called a random variable, right? Generally, for example, here I am going to explain to you. Example: if you are tossing two coins, so on tossing two coins, what we will get? We will get the sample space. Like both the coins you may get a head, right? And one will get head and one more will be tail. And first coin will fall tail and the second coin will fall head. And next, both the coins you may get tail. So these are the four are the chances are there when we are tossing the two coins, right? Okay. So here what is the events of the sample space? Here this will be the S will be the sample space. In the sample space, what is the first outcome? H and H. That means both the coins will fall head. And in the second one, first coin fall head and second coin will fall tail. And in third one, first coin fall tail and second coin will fall head. In this fourth one, both the coins will fall tail. So in this scenario, we are going to define a random variable. Generally, the random variables are denoted by the capital letters like X, capital Y. Generally, we denote the random variables as a capital letters, right? So, in this example, how we are going to defining the random variable? See, let us say here X is a random variable that I'm going to defining getting number of heads. So here what is the random variable? We are defining number of heads. For example, the sample space, the same sample points here I am writing HH, HT, TH and TT. So what is our random variable? X. What is the X? Number of heads, right? So in this event H and H, how many heads are there? 2 heads are there. So this will be maps to some number like 0, 1, 2, 3, 4, 5, like this expanding. So in this case, H and H maps to which point? That maps to 2. And HT that maps to 1. because number of heads in this case will be only one head. So this maps to 1. And TH, this maps to also 1. Here also number of heads will be 1. And TT, here the number of heads will be 0. So this point maps to 0. Right? So this way we are assigning the outcomes. Outcomes. What are the outcomes here? HH, HT, TH, and TT. These are the outcomes of tossing 2 coins. So in this way, we are assigning the outcomes to a numerical value. Right? So here X will be the random variable. In this case, we are defining the random variable as number of heads. One minute. Okay, in the next one. So, types of random variables. How many types of random variables are there? In generally, there are 2 types of random variables, and one will be discrete random variable, and another will be continuous random variable. So, what is the meaning of discrete random variable, and what is the meaning of continuous random variable? Discrete. Discrete itself, we can understand easily. That is a discrete values. Suppose x will be the random variable that takes the values. Suppose in the earlier example, here x will be, we got 0, 1, 2, right? Because the number of heads, HH, that will be 2. HT, that will be 1. TH, that will be again 1. And TT, this will be 0. So, here x takes the values 0, 1, and 2. These are the discrete values. These are the discrete values. So, in this case, here x is called discrete random variable. Discrete random variable. Right? Okay. If it is the x takes continuous values, once again, in this case, here x takes 0, 1, and 2. Only takes 0, 1, and 2, but will not take x 0.1, and it not takes 0.2, and it does not take 0.5. These are not taking this. Only takes 0 and then 1 only. So in between 0 and 1, there are infinite values are there. But we are not taking that infinite values. Okay? We are not taking that infinite values. We are taking only the discrete values 0 and 1. Okay. So in this case, x takes 0, 1, and 2. That means these are the discrete values. So taking the discrete values means here x will be called discrete random variable. Discrete random variable. Right? Next, what is the meaning of continuous random variable? Continuous random variable means the random variable that x takes every value within the given interval. For example, here I will write some experiment is going on in the lab, in our lab or somewhere. Some experiment is going on. Whenever you started, the starting time will be 0, lap starting time will be 0, and your time is going on, up to 1 hour, that means 60 minutes. So here what is the interval? 0 to 60 minutes. In this, every minute and every second is also counted. Every fraction of second also counted. Every nanosecond also counted. So here every value will be counted. So in this case, X takes every second, every fraction of second, every nanosecond, every millisecond. So that takes every value. So in this case, we will call as continuous random variable. Okay. Okay. Next slide. So here again, typically denoted by, that means the random variables are typically denoted by uppercase letters such as capital X and capital Y. Next, probability distribution function. So what is the probability distribution function? Generally, probability distribution function is called PDF, describes the likelihood of different outcomes of a random variable in probability theory. Right. It provides a comprehensive way to understand how probabilities are assigned across possible values of the random variable. Let's say what is the definition of this random, right? Probability distribution function is a function that gives probabilities of occurrence of various possible outcomes, right? Probabilities of occurrence of various possible outcomes for a random variable. For example, a random variable capital X, the PDF can be expressed as capital F of X equals to probability of capital X less than or equals to small x. So this way we will define the probability distribution function. Simple. What is the probability distribution function? Let's see. Let's have small example based on this. Okay. On tossing two coins, so what is the sample space we will get? We will get both the coins may fall head, and one fall head and another fall tail, and one fall tail and another fall head, and both will fall tail. So total number of sample points here will be, assume that n equals to 4. So here we are defining the random variable. X equals to random variable, that is number of heads. Number of heads. So the number of heads may be 0, maybe 1, maybe 2. Now I am going to define the probability distribution function. That defining as probability of capital X equals to 0. Probability of capital X is equal to 0. So how can we define? In this case, the total possible ways are 4. The total possible outcomes are 4. Out of 4, how many times we are getting the number of words will be 0? Only one time. In this case only number of words will be 0. That means how many times that repeated? Only one time. 1 out of 4 times. And if it is probability of x equals to 1, that means what? How many times we are getting probability? Sorry, how many times we are getting head? So out of 4 times, 2 times, here we got one head, here also we got one head. So 2 times. So 2 out of 4 times. Right? And next what? Probability of x equals to 3. That equals what? Out of 4 times. Sorry. Here x equals to 2. So how many times you are getting number of heads equals to 2? That means only 1. So only 1. In this case only we have 2 heads. Right? So only 1 out of 4. So here probability of x equals 0, that equals to 1 by 4. Probability of x equals 1, that also 2 by 4. And probability of x equals 2 equals to 1 by 4. So these are called distribution values. Probability distribution values. Distributing like this is called a probability distribution function. See, function that gives the probabilities of occurrence of various possible outcomes for a random variable. So this way we are defining the probability distribution function. Right. Okay. Next here types, probability distribution function types. So aspect, function name and discrete random variable. If it is a discrete random variable, then the probability distribution function is called as probability mass function. When x will be a discrete random variable. Next, if x will be a continuous random variable, then the probability distribution function is called probability density function. And how can you define this? That P of x equals to probability of capital X equals small x. This is the way we are defining. And in this case, small f of x is equals to the derivative of capital X. When if you're differentiating this, you'll get f of x. Here f of x is called probability density function. And how to calculate the probability? Generally, probability of a less than x less than or equals to b, that equals to sum of x equal to a to b and p of x. So if you want to find the probability from a to b, just we need to add sum all the probabilities. But whenever x will be the continuous random variable, how can we calculate? To calculate this, we need to integrate from a to b. We need to integrate from a to b, then we will get the value. That calculated value will become the density, probability density function value. And important property, total probability. What is the total probability here? Sum of all probabilities equals to 1. If you are finding the probability for each event and add all the probabilities, the total probability, sum of all the probabilities will get 1. Then the probability is called total probability. That probability should not exceed 1. The maximum probability is only 1. Already we know probability should be only lies between 0 and 1 only. So the maximum probability will be 1. So that is the total probability. And in this case, area under curve equals 1. So whatever the function will be there here, for that function, we may have some graph. Draw the graph from point A to point B, this area. This total area will becomes only 1 unit. Okay. This way, we can define probability distribution function.